Hi, in this video we are going to talk about how to create Eric's polygons for harmonic studies. So for this I created a script which automates this whole process. It's called Eric's polygons version 1.1. Okay, we can see that as an input parameter it has a path to a folder, and in that folder it's an input file, it's an Excel file in which is a table. In that table, the user will introduce the contingencies needed for determining the polygons. We are going to talk about these files soon, very soon. In the external object, we have the point of connection. Is the bus actually where all the measurements are going to take place. We can see that this point of connection is marked on this diagram with a red circle. Okay, so let's go in description to see how the script is divided. So we can see that we have three main parts. First part is creating the contingency scenario, which is based on that input file that I previously showed. Second step is determining the X polygons, and in the third step, the script automatically creates a folder in which it saves the plots as PDFs. Okay, so let's take the first step. So creating the contingency scenario. So for this we have that input file. We are going to open it. So here is a table in which the user must introduce in columns the contingencies that he needed for creating the polygons. So we can see that first three lines are with blue. In these lines, actually in first line, the user must introduce the class of that object in the network. The third row is the attribute of that object, and from fourth row downwards, it can create the scenarios, and in each cell is going to introduce the value of that attribute of that object for that particular scenario. So for instance, for here in second column, we have line 414, which is an LNE class. The attribute out of service is going to be 1 for first scenario, I mean out of service, and 0 for the other scenarios. Is going to be in service. Yeah. So in this way, the user can create how many contingencies he wants very easily. I'm going to put this aside. Okay, so first let's create the scenarios. Just execute the script. Okay, you have here three options. We are going to choose the first option. Some presentation and some warnings. Okay, in 12 seconds, the scenario has been created. You can see here in the output window that some information that in each scenario, what attribute of what object has been modified to what value. Yeah? So you have here a detailed preview, let's say. Yeah? Now let's check this. By the way, with the green circles are the objects that are going to be out of service in our case. Yes? So let's activate first scenario. Immediately we can see that this line has been made out of service because is gray. We are going to check the name of it. Is line 414, and if you are going to go in the input file, line 414 is going to be out of service for first scenario. and in service for the rest. In this way, we can check all the elements, but no need for now. Okay, now let's go to the second step. Just execute the script. Actually, let's see it. Is determining the Rx polygons with all the subpoints. Execute. Right here, choose second option, determine Rx polygons. Okay, we can see now the script is working. It's completing the frequency sweep. Yeah, the measurements of this point of connection for each harmonic order. We can see here at each step, but I will let the script finish its work and then come back for explanation. Okay, the script finished its work. We can see here that some plots have been created. I'm going to show them soon. As you can see here in the output window, we have all the steps, and of course, a report is have been created. As you can see, now here we have a report, and we're in the path where the input file is. We have a report, which we are going to discuss about it soon. But first let's take step by step. So in description we have here initialize harmonic load flow and frequency sweep. Okay, let's look inside the script actually to see. Okay, we have around here, as we can see, we have some settings for harmonic load flow. You can check them inside the script here. But what are more important is the settings for frequency sweep here. You can see these are the settings, but what we can notice is that we are not going to start from order 2. We are going to start a little bit below. Yeah, 90, 80, doesn't matter. We are going to choose a frequency step of 1, so the measurements are going to be taking place from 1 Hertz with a step of 1 Hertz. Okay, and frequency stop is a little bit above the 50 order, so we are going to go to 2600 Hertz. Yeah, this is very important. Why? We're going to start at 19 and finish to 2600. That because we are going to have a margin above and below each order from which we are going to collect our R and X values. Yeah, that margin is given by the frequency tolerance band. We're going to discuss about it. Okay, here second substep is run frequency sweep for each scenario and retrieve Rx pairs. Yeah, this thing, as you can see here, is done here, and as you can see, the third step is save tolerance bands values for R and X and store them in matrices. In this way, the cloud of Rx pair is formed. Yeah. Okay, we are going to see here that the script is computing a frequency tolerance band that has two components. One is, as you can see here in this formula, yeah. Wait, it's in this formula. Is here with one is system frequency variation is going to be plus or minus 0.5 Hertz, so 1 Hertz in total. And the second part is the component tolerance. It is this part in which is going to be plus or minus 5% of that order. Yeah. So maximum of these two is added or subtracted from each order. So this band, the values from this band at each order are going to be The values are going to be read for r and x and stored in some matrices for each order, and it is called the cloud of Eric's pairs. Yeah? Okay, let's go further. After computing the cloud, the script creates the impedance for each order. Okay, let's look here. As you can see here, contingency 1, this is the impedance of each order till the order 50. This is for second scenario, for third scenario, so on and so forth. Yeah. Okay, after creating the plots, now we have this cloud points. Yeah. We want to determine the convex hull. Yeah. And for this, we are going to use the Graham scan algorithm. This algorithm I presented in detail in one of my videos. As you can see here, Graham scan algorithm for creating the polygons in the harmonic assessment. It's an old video of mine in which the algorithm is presented in very detailed, yeah, very high detail. Okay, after this, the script creates an Eric's polygon plots in which we have the clouds along with the convex hull that have been determined with the Graham scan algorithm. So let's look. Okay, let's choose any order. As you can see here, this is the cloud of points at n x, and with the red are the extrema points, yeah? Determined by is the convex hull, the polygon actually determined by the Graham scan algorithm. We can see for any order we want. Yeah, the algorithm every time chooses the extrema points. Okay. Further, here we have generate report.xlsx. So we can see here in this information in the output window information that each sheet have been created, yeah, and in the final two sheets are Eric's data and tolerance band Eric's data. So very important, we have two kinds of polygons. So the script gives two kinds of polygons. We're going to see what is all about. Just open the report. Okay, I'm going to let this aside and we can see. So in Eric's data, the script retrieves for each order, yeah, it retrieves the for each order each contingency, yeah, but each order. So we have 7 contingency. We have all polygons have 7 vertices. Yeah? Yeah, and we have tolerance band, which we discussed. Here, the polygon have different number of vertices, as you can see. Actually, these points, yeah, are exactly the points with red, yeah, are exactly this point that determine the polygon. We can go to any order we need. So very important. The script gives either exactly the RNX pairs for exactly exactly order 2, 3, 4, 5, so on and so forth for each contingency, yeah? Or it gives you the exact polygon, the how you call it, the convex hull. Yeah? As you can see, we have other other sheets here in which we save the RNX values from 90 to 2600 with the increment of 1 Hertz. So the user can take this data and I don't know, analyze it, make further simplification to the polygons. He can do whatever he wants to it. Okay, so now now that the polygons are created, we are going to go to the last step, in which creating the plot folder and save plots as PDFs. Okay, so for this, what we are going to do now, just first let's look at the path, the folder. We have only input file and the report file. Here is going to be automatically created another folder with the polygons. Just execute the script, create path 3 for third option. As you can see, it's iterating to each plot, to every plot, and it automatically creates this folder in which inside is our PDF files. As you can see here, for instance, we have this plot, or order 44, let's say. Yeah. So that's it. This is the script. I hope that you enjoyed the video. Thank you so much.